Okay, guys, so we are on our last lesson for our quadrilaterals, and it's going to be looking at trapezoids and kites. So let me preface by saying that I also have made another visual aid video to talk about what the properties of trapezoids and kites are. Okay, um, so you'll need to go watch that first, so that you understand where the properties come from that I'm going to talk about in this notes video. Okay, so you go watch that first, and then you come back here to get the notes. Okay, so let's start doing the notes. So, trapezoids and kites. I'm going to start with the trapezoid. And I'm going to go over like the anatomy of a trapezoid. In other words, the pieces that make up a trapezoid. And so this is just a regular old trapezoid. Trapezoid member has exactly one pair of parallel sides. And then we call those parallel sides, we call them the bases. So this one's a base. You can call it base 1 if you want to. And this is base 2. The non-parallel sides, we call those the legs. So then this is a leg, and then this is a leg. Okay? And then two angles that share a base of a trapezoid. So in other words, two angles that touch the same base. So, for example, the two that touch base 2 would be this angle here, this angle here, and this angle here. Those are called base angles. Okay? So base 1's angles are up here, base 2's angles are down here. Okay? And then, as always, anytime we have same side angles, same sides are always supplementary. Okay, we have to use that some today. So, anytime we're talking about same side angles, it is always supplementary. They're going to add up to 180. So now let's look at this theorem and this opposite angle property. This technically really isn't like a special thing pointed out, but I thought I would point it out here for you. So this is now these are about isosceles trapezoids. Remember, and what makes it isosceles is that the non-parallel sides. So in my picture here, the ones that look parallel would be this side AD. So you could add your parallel arrow there if you wanted to. And BC. Those are my parallel sides. My non-parallel sides would be AB and CD. If we mark those as being congruent, then we have an isosceles trapezoid. Okay? So in an isosceles trapezoid, the base angles are congruent. Okay? And that's what I showed in the visual aid video, that the angles they touch the same base. So BC and then AD, they are the same. So whatever A is what D is. Whatever B is what C is. Now we can mark that by saying like, hey, let's give this top pair one angle mark or angle arc. And then, nope, I can draw it. These two on the bottom, they'll get 2. So that shows us that these two are the same and these two are the same, but then this way they're different. And actually, A plus B is going to equal 180 because they're the same side. Okay? Now, opposite angles. In an isosceles trapezoid, the opposite angles are supplementary, and I showed you that in the visual aid video. So if this one is 100, this one's 80. If this one is another number like 70, that one's 110. They're supplementary. And that should make sense, because let's say you know this one and this one, you can scooch this one over here to the same side, and that we definitely know that same sides are supplementary. Okay? So remember, in an isosceles trapezoid, the opposite angles are supplementary. It's the only time opposites are supplementary is in an isosceles trapezoid. Anyway. Okay, so let's go look at some trapezoids. So I told you this is an isosceles trapezoid, so we know, I mean, you don't have to mark it if you don't want to, but we know that and that is parallel, that and that is congruent. Measure of angle B is 36 degrees. Now I want to find A, C, and D. So I'm going to write those out. All right. To me, the easier one to find first would be C, because we know C and B are on the same base. They're both touching that base. And because this is an isosceles trapezoid, base angles are congruent. So that one has to be 36 degrees. Now, how do we get A and D? Well, remember, you can either think of it as doing the same side or the opposite. I'm going to go with same side. A and B are on the same side of the trapezoid. This one's 36. So I can do 180 minus 36 and get me A. And when I do that, that gets me 144. Which automatically means that D is 144. Because A and D are on the same base. Okay? And I can add those in here if I wanted to. Okay, I need to solve for x on this next one. It's an isosceles trapezoid. They've given me a pair of opposite angles. So remember the property that the opposite ones are supplementary. So we're going to take 26x plus 102 and equal it to 180. Because opposites are supplementary here. Now we'll just subtract 102. And that's going to get us 78. Divide 26. And x equals 3. All right. Solve for x and find an angle measure. So they want B when we get done. They're on the same side, so I'm still going to take them and add them together. Let's combine 30 and 80 first. Gives us 110. Now we'll subtract the 110. So x was 10. And now angle B, they want that one, so that was this expression here. So the measure of angle B is 7 times 10 plus 30. That's going to get you 100 degrees. And you can't see any of that I just wrote, so there you go. Sorry about that. A quick note on this kind of problem. They could ask for an angle measure that was blank, like one of these over here. And so what I would do is you would want to find one of these first and then subtract it from 180 to get this one, because that's how you would need to do it. It just depends on how the problem's written. If you get to those kind of situations and you're confused about it, just let me know and I can help you. Okay, but it shouldn't be too bad. All right, now let's go look at a kite. So kites are a little bit weird. First of all, they look a little strange, and then they have a couple of properties that are obviously shared with other quadrilaterals. With the big one being this one that I showed you in the visual aid video. In a kite, whoops, I started to write the word the again. The diagonals are perpendicular. Meaning, what's perpendicular mean again? It means they cross each other and make 90-degree angles. So the diagonals going this way, they make 90-degree angles. Now I just put 2 in there, but obviously all 4 of them are 90, okay? So that's a big one. These 2 are more like properties that kind of happen. And I want to point them out to you because most textbooks and the way teachers teach this, they kind of just embed this one and talk about it when it shows up, but I want to point it out ahead of time. Okay, so the opposite angles. In a kite, there is exactly one pair of opposite angles. That is congruent. So in a kite, there's only one pair of angles that's going to be the same, and they're opposite each other. And to give you a hint to where it's going to be at that I showed you in the video, it's going to be that angle between the short and the long side. So like I said, we said in that video, this is the short one, this is the long one. This entire angle right here is the same as this one. Okay. Notice I said nothing about them being equal, the little pieces of the entire angle. So I would say angle KJM is congruent to angle KLM. KLM, KJM. It's the whole thing. Okay. And the last one is about a diagonal. In a kite, one diagonal bisects one pair of opposite angles. And this pair of opposite angles is the pair that's not congruent. So the way you kind of remember the difference is the congruent pair of angles is they're across on the shorter diagonal. Okay? The longer diagonal is the one that's going to cut it in half. So this is the shorter one. This is the longer one. The longer one is the one that cuts it, these 2 angles in half, K and M. So we can say this piece of K and this piece of K are the same length. And then this piece of M is the same as that piece of M. Okay? So there are our properties. Let's use them, and we'll wrap this up. All right. So we know that the measure of angle M is 90. So M is right here. So we could put our little 90 box right there. And P is 54 degrees. They want N and Q. Well, how are we going to find that? Well, remember, N and Q, they are both between the short and the longer side. So that means that from earlier that N and Q are the same thing. We just don't know what they are. Okay? So if you want to, you can kind of call it like X, because they're both going to be X. Okay? And then here's what I'm thinking. We know it's a kite that has 4 sides. And we learned at the very beginning of this unit that when you have 4 sides on a shape and you add up every angle inside that shape, no matter what it is, it's going to equal 360. That's what we're going to do. We're going to add up every angle inside here and equal it to 360. So I would start with the x's. X plus x plus 54 plus 90 equals 360. That's what I would do. Combine like terms, that's going to be 2x's, and then 54 plus 90 is going to be 154. No, that's not right. Hang on, that doesn't sound right. I don't trust myself in my head. 90 plus 54. Yep, I was not right. That's 144. Now we'll take this away. So 360 minus 144 equals 216 divided by 2. X equals 108. And so the measure of angle, remember X was what the actual angles were, so now we can go ahead and say what they are. That's what I would do for that kind of problem. Okay, so last one, the measure of angle MOR is 32 degrees. They want us to find all these other measurements. And I'll go ahead and tell you, these last 3 we actually can't do. I got to do in my own separate note copy and realized that we don't have enough information to find those. So you can go ahead and mark those out on yours. We can't find those. But the rest we can find. Okay, the measure of angle ORM, it's right here. It's where the diagonals intersect each other. And remember, we said that when the diagonals of a kite intersect each other, everybody there is 90. So this angle is 90 degrees. Okay? Now they want OMR. They want this angle up here. Well, now how are we going to find that? Well, notice that we have a triangle. Let me highlight it out for you so you can see it. Color it in. We have this triangle inside our shape. but I colored it like a little teal color. And we know that one angle is 90 and one angle is 32. We can easily find the other one by taking 180 minus 90 minus 32. Why can we do that? Because all three angles in a triangle add up to 180 degrees. And when you do that, it's going to be 58 degrees. So this angle up here is 58 degrees. Now they want ROH. I can't read. ROH. This angle right here. Well, it's sitting next door to 32. And notice that 32 and the angle we want are both on the longer diagonal. So that means that whatever this angle is, it's also going to be that one. Remember, because this entire angle O has been bisected by the diagonal. So this angle is also 32 degrees. Okay? And then finally they want the angle of HOM. HOM. Notice that would be both of our 32s, or 32 times 2, or 32 plus 32, which would be 64 degrees. Okay? That's it. That's all about that's kites and trapezoids. So make sure we've watched this all the way through to get the notes and we understand it, and that you've watched the visual aid video to understand where the properties, how the properties come about, and then complete your homework assignment. And as always, if you have questions, let me know.